Hello everyone. My name is Sergey Potanin. I've been working for Wrike for 4 years. Thank you. I work as key automation team lead right now. And let's talk about Wrike. And let's talk about Wrike in terms of testing. Well, first of all, Wrike has been developing for more than 10 years. Therefore, the application is huge and complex, and in terms of testing, of course. And we have a lot of features to check. And the most important part is we have to check everything daily, because, as you know, we have daily deploys at least once a day. And it's obvious that we just cannot test everything manually, so we have auto tests. And how many tests do we need to test everything? What do you think? Well, you can think I have a microphone.
Can we switch to the normal microphone? Yes, we just switch to that one. Okay. Awesome.
Check. So, how many tests do we need? What do you think? Oh, I prepared some numbers for you, and we have 17,000 of Selenium tests, 5,000 REST API tests, and 41,000 backend unit tests. And you could look at those numbers, and now you probably have a question. Right? What is wrong with our test pyramid, right? Well, this test pyramid is, it even doesn't look even, right? And isn't it a huge anti-pattern to have so many end-to-end tests? And my answer is, well, yes, but actually no. Actually, it's not as simple, and in fact, it's not as bad as you could think it is. And I'm going to tell you a short story. A couple of years ago, we had approximately 80% less number of tests, and our QML engineers, front-end developers, and even some back-end developers started to write Selenium tests. And how many of you ever wrote a Selenium test? Raise a hand. Right? Okay. And my colleague will later tell you about how did we get there. But what about auto tests? Those numbers started to rise really fast, and we calculated them every month, and we calculated monthly test increase, and we started to realize that very soon we just wouldn't be able to run all these tests properly. And we started to think what to do, how to handle all of them. And we came up with 3 main questions. How to run so many tests, obviously, what tests to run, and when to run the tests. And look at this picture. This is Wrike. This is one of our main workspace views. And we have, as you could see, a bunch of parts or components. Bigger ones like folder tree or task list, or smaller ones like assign list. But let's consider example with the comment section. Well, once we had an idea that it would be really nice and convenient if you could not load the whole application in a view, but pick just one component and load only those without loading anything else. And now we have this possibility. This is really a way faster and more stable. And I've prepared some demo of 4 component comment section tests run locally. Well, as you could see, for browser start, then page went blank for a couple of seconds. Then we just have to load the application, made a couple of clicks, and that's pretty much it. So what I tried to tell you by showing this. Not every our Selenium test is actually end-to-end tests. Well, during the time that browsers went blank, we were preparing our needed data, test data, via REST API. So we've created accounts, created users, created tasks, comments, etc. And then we just had to open the only one small component, make a couple of clicks, one check, and that's it. So those tests are really basic and fast. But we still have 8,500 of tests that actually close to end-to-end tests, but they are also prepared via REST API. And it's still a work to do for us because we are trying to turn the biggest part of this test to the component tests. And how do we use these component test packs? Well, this is a deploy schema for our front end. Let's suppose we have a front end branch in a front end repository, and it's ready for testing. So what we have to do? We have to run the component test only for those components that were affected by this branch. And we have to also run the smoke pack. Those are the minimum number of tests for the maximum number of elements tested. And after we have this test passed, we can merge this branch to the RC integration branch. And then we have to run all the tests because we actually didn't know how all these branches will interact with each other, and we must check the application behavior as a whole. And after this, we can deploy. And our goal here is to get rid of this part, and it's also a work to be done, and those branches must be independent, and those components must be independent to do so. And as we still have a bunch of tests that we have to run daily, we must have an ability not only to run all these tests, but to launch them as smoothly as these missiles. And we have a solution for this, and the solution is in cloud. And we have two main cloud solutions to solve this problem. First one is dynamic stagings, and the second one is self-made analog of Selenium grid. So about dynamic stagings. Those allows us to run the application for the particular version of backend and frontend, and we have some benefits of it. So first benefit is scalability. So we actually have an ability to run as many application instances as we need, and we can easily tune each of them by just editing the configuration files, which is very convenient. Code isolation, so we just there's no more worries about conflicts in code, and we do not have to worry about the changing of or some intersections is in product behavior between the branches. So no idling, so we're able to run the application for this particular time that we need and no more. And no queues. Well, queues used to be a huge pain for us because the static staging performance is limited, and we just couldn't run all the tests at once for all the branches, and sometimes we have to wait for hours to run the tests. Now everything's great. And what's wrong with Selenium grid, right? At start, it was all good and well until we started to launch the tests with 2 threads and more. And then we started to get test failures with 504 errors, socket timeout exceptions, browser unreachable exceptions, etc., etc. And now we have our own solution. We call it Selenium Farm, and this farm is actually work with clouds. And every time when Selenium sends a command to open a new browser instance, it opened in a brand new virtual machine that one time used. And after all, we are now independent of the number of threads. So what are the results? So the main result is full regression time. As I said, a couple of years ago, we had 2,500 of tests, and we were able to run all of them in 80 minutes. And now, when we have 17,000 of tests, we can run them all in 60 minutes, which I think is impressive. Well, I think at this point, Wrike automation is going great, and that was not it. I want to turn the floor over to my colleague, Stas Davydov. Please give him a round of applause.
Yeah, I switched on. Can you hear me? Yeah. Okay. Do you hear me well? Hello, everyone. Are you alive still? Okay, okay. The clicker works? Yeah, that's me. So, Sergey was talking about how we run tests. So, imagine that you have everything covered with tests, and you know how to run these tests in less than 1 hour in our case. And so, can we do anything else to improve the question and the answer? Okay, let me briefly explain our testing environment. So we have about 1 million lines of code and more than 100 test developers. And in such conditions, the question is, what could possibly go wrong? And what should I say now? Someone knows what could possibly go wrong? What? In that type of conditions, your code will eventually look like this. It will be a rubbish bin. It will be unreadable, unmaintainable. And if this happens, you have two options, either to refactor your code or to rewrite the whole project from scratch. So we chose the second option in 2016, and it was quite painful, I must say. So in order to prevent these problems in future with our new project, we decided to build a kind of border between test developers and the master branch, and not this type of border, but more like this one. And this border is a code review. I don't mean that we didn't have a code review. Of course we did, but it had a lot of things to improve. And here are some of them. The first one is how to know who will be the reviewer of your code. So we have a lot of reviewers with a different skill level and areas of responsibility. So firstly, we tried to write review requests in our chat. But, well, you know what happens when you ask a group of people instead of someone particular, no one wants to take responsibility. So then we tried to assign requests manually, but it was quite unfair. So the one reviewer could have, for example, 5 requests and another one 0. So everything we tried to do manually sucks. The second problem with review is sneaky developers who try to merge their code and master without review. And there are a lot of them, I found out, and more than you might think. And the third problem is review time. So I guess many of you had problems with when the time is running and your tests are not, because the code's stuck in review. And in order to solve all of these problems, we decided to build our own GitLab tool, which is called Git. Git is a Russian word for a skilled horseman, by the way. So it helped us with selecting a reviewer. So it could pick a reviewer from the list according to how busy they are, what the area of responsibility of them, their skill level, and etc. The second thing it can do is to control workflow so that no branch and no commit could be merged into master without review. It will just not allow you to do so. Thirdly, we now can collect and control metrics so that we knew who is our best test developer, who is the quickest reviewer, and what is our average review time, and so on. And last but not least, we've been able to decrease review time dramatically. So it sends notifications in Slack to author of branch and reviewer with all the important changes in review process so that they know everything just right there. And before implementing Git, we had more than 100 hours of average review time, and after that it decreased to less than 40 hours, which is great. So the review is a kind of solid stone wall. It's a very powerful, reliable mechanism which allows you to increase the code quality, but it's a bit expensive in terms of human effort and time. So how could we soften it a bit? How could we prepare our test developers to pass review easily? How could we get rid of a lot of mistakes before review? And we found out that there are some tools which could help with static code analyzing. I guess some of you have heard about them. Have you ever see these things? Yeah, excellent. So these tools can scan through the whole project, searching for any mistakes and report you about them. But we can do better than this, like a piece of cake. And sorry, guys, I know you're hungry, but talking about cakes, let's pretend that our test project is a cake, and the slice is changed files in your branch. So why do we need to check the whole project all the time? Why can't we check the changed files on it? And we configured pipelines in GitLab that check every push to every branch. And the tools we use is a check style and PMD. The check style checks whether your code obeys the code style rules you have. And PMD have rules like unused variables, unnecessary object creation, empty cache blocks, and etc. And we do also have our custom rules in PMD related to our test project. And moreover that, we have some IntelliJ IDEA plugins which work like magic. And one of them, for example, run all these static code analyzing checks right away, right on your computer. So that's an example. For example, you've changed your code, system out hello, and you're making a commit, pushing it to remote repository, and plugin asks you to run the checks. So you click the button, all these checks are run right on your machine, and you get a readable report about what is wrong if there is some problems with that. So you can return to your code, fix it right away, and by the way, the report is readable, so it will not be a problem. Make a commit, push it again, run all these checks again, because when you are fixing something, you can break another things. And if everything is fine, that you can be sure that your code is prepared to review, and the reviewer will not have to spend a lot of time. So that's about static code analyzers, and you might ask me, where did all these test developers come from? So that should be a picture here. Okay, we had one activity that helped us to get such big number of developers, and it's called QA Automation School. We've conducted several lessons for our colleagues and recorded them on video, and now we have a knowledge base which allows you to onboard newcomers easily. So we taught them how to run the test properly, all of our tools, the latest improvements in project, and so on. And as a result, we have about 80 new people writing tests, and we increased skill level to appropriate level. Sorry. So in Wrike, we do not only write tests in QA automation team, but we also have QA engineers, front-end developers, and back-end developers writing tests. It's more convenient for them and for us. So we have about 20 people in QA automation team and about 80 in other departments. And another thing we have is so-called technical talks every week, when anybody here can bring up their ideas, can share their knowledge, and talk about the latest improvements and so on. So now we are great, I suppose. But can we improve something else? Yeah. Yes? Okay, Ivan will talk about some other things that we can improve. Give him a bit of applause, please. Thank you very much.
Thank you, Stas. Hi, everyone. My name is Ivan. I am co-automation technical lead, and right now I want to tell you about such interesting topic as test fragility. This property is more relevant to selenium tests than to integration or unit test, and probably you know this test as flaky test. And before we continue, I'd like to ask you, who saw any flaky tests today? Please raise your hands. Yeah, guys. Selenium tests are not very stable, unfortunately. And if you Google why Selenium test, the first result will be why Selenium tests are flaky. This is really true. And right now I want to show you an example from our real life. In Wrike, as Sergey has said, Wrike is a big and complex web application, and every day we deploy about 30 tasks. And we always ran some web tests. And last week we have a technical task with some code refactoring, and as always we ran some web tests. And we expected that all tests would pass, but we got one broken test. And when we restart this test, it passed. This is magic. There was a real flaky test. And what is the problem? In this case, we spent about 5 or 10 minutes for investigating and restarting this test. And right now, imagine that you have about 100 test builds like this, and each 10th has flaky tests. In this way, you have to lose, you will waste about 8 hours your time. Stop wasting your time. And the main problem is that test fragility slows down your development and deployment. So, how can we solve this problem? The first things come to mind, don't write flaky tests. It's very easy. But we are not robots, and each of us makes mistakes, it's normal. And right now I want to tell you about our solution, which we call isolate and fix. The main idea is very simple. There are 2 steps. First of all, we have to isolate flaky tests. And after that, we can fix them. This scheme looks like a pit stop, where instead of car is our test. And right now, I want to show you how we isolate flaky tests. For this purpose, we have test quarantine system, which consists of storage of quarantine tests. This storage stores information about which tests right now are in our test quarantine. Also, we have custom test runner. It allows to avoid isolated tests during test run. And finally, we have control system of quarantine. The system analyzes all our isolated tests. How does it work? Imagine that you have some web tests and you don't need to run isolated tests. As you know, in Wrike we use Allure server as test management system, and all information about our isolated test we store there. And also we have custom test runners for JUnit 4 and JUnit 5 test frameworks that works as follows. First of all, test runner gets all information about isolated test from Allure server, and after that excludes this test from our first pack. And finally, we run only necessary tests. On this video, you can see how we can put our test into test quarantine. We have to click on button, fill some fields, specify ID of task, which we link it to this isolated test, and click on mute button, submit button, sorry. And after that, after these actions, this test won't be run by our test builds. This is a manual way. We also have automatically ways to put this test into our test quarantine, and I will tell you about it later. So, what about control system? This system runs only quarantine tests every day. After that, remove some tests from quarantine automatically. These tests are determined by status of task, which we link it to this isolated test. And after that, this system notifies test owners about these actions. On this slide, you can see an example of this message. Our bot sent information about that we had 12 tests that were successfully removed from our test quarantine. And there were some notifications. So we have discussed how isolate flaky test in brief, and what about fixing flaky test? Unfortunately, this topic is out scope of this presentation, and I hope you know how to do it, how you can stabilize your test and improve your test. And instead of it, I'd like to tell you about how to find flaky test. And this example, it was pretty easy because we had only one test build and only one broken test, but we have 17,000 web tests and 100 test builds every day, which run some web tests. And in this case, we have to find flaky test automatically. And for this purpose, we have another system, which name is test monitoring system. It's a Spring Boot application with own database. This system analyzes success rate of all our web tests, notifies test owners about tests with low and bad success rate, and after that puts flaky test into our test quarantine automatically. And on this slide you can see an example, a message which sent our bot. It means that we had 78 tests that were unstable on our deploy and some notifications test owners. And this chart presents information that every day some test, our system add and remove some test into and from, add our test into quarantine and from this test, from our test quarantine automatically. This system works fine. And summary, today we have discussed automation in Wrike, about our test infrastructure, how you can run tests in parallel, how to improve code quality, how to struggle with flaky tests using test quarantine. Thank you for your attention and enjoy your beers. Thank you.